Assalamualaikum and hello everyone. We continue chapter 9 mechanics of material, buckling of column. This is the last subchapter. Previously you already learned how to analyze the unbraced column. For your information, you have two types of column, which is unbraced column and braced column. There is slightly a different analysis for braced and unbraced column, but the fundamental concept is same. For this lecture, we would like to analyze the braced column. Braced column is a long column, but you put a brace in the middle or in the top of the column so that it can sustain more load compared to unbraced column. So if you look at this diagram, for unbraced column, when you apply the load, it will bend. To avoid a bending of the column, sometimes we will put a brace in the middle of this column so that it will sustain more loads and it will not buckle when you apply the excessive load. And besides, the brace here also has a function to cater a lateral forces. A braced column and you have a lateral forces here, then it will not sway, it will not move, or it can resist of movement. So this is an example of braced column. So if you look at here, this column, for braced column, you need to put the X and Y axis. For example, if the statement states that it is a column at X axis brace, then you will have these braces in X directions. When it will buckle from here to here, and then at the brace it will reflect until it goes here. Same as unbraced column, you need to analyze in X and Y directions. So for here you will have Rx and Ry, PCRX and also PCRY, and then you will see which axis the column will buckle. Let's take a look at the first example of a braced column. Read the question. The aluminium column is fixed at its bottom and is braced at its top by cable as to prevent a movement at the top along the axis. If it is assumed to be fixed as its base, determine the largest allowable P that can be applied. Use a factor of safety for buckling is equal to 3.0. Take modulus of elasticity for aluminium is equal to 70 gigapascal. Yield stress is equal to 250 megapascal. The area 7.5 times 10 power of negative 3 meters square. IXX and IYY is given. If you look at this figure, the column is braced at X axis. This is your X axis, while the opposite is a Y axis. And then you need to determine the allowable load. What is your allowable load? Given to you, the factor of safety is equal to 3. Then you know that to determine the allowable load, you have a factor of safety formula, which is factor of safety is equal to critical load divided by allowable load. This one you need to find. PCR you can determine by using Euler formula, pi square EI over LE square. And you know that here it mentioned this column is fixed at its bottom. Usually, if it is braced, we will have a pin connection for brace. Let's take a look how to analyze this column. First, we need to determine X as buckling and also YY buckling. Because it is braced at the top and fixed at the bottom, then you will have a 2D diagram. Here is 3D diagram. I will draw the 2D diagram. This is your brace. Usually it is pinned at the brace, and here is fixed. The total length is 5 meter. To analyze a brace column, first you need to determine the effective length of the column subjected to X-axis buckling and Y-Y buckling. For X-axis buckling, in a simple word is you look from X view. Means that you look from here. For example, this is your eyes. You look from here, from X axis. If you look at from X axis, you only can see a fixed connection, and you cannot see the brace because when you look from X, the brace is just a dot. So from X view, you will see it is free and fixed connection. The length is 5 meter. So if it is fixed free, then LE is equal to 2L. And the buckling shape from fixed to free is mirror image. So your LE is actually 2 times 5 is equal to 10 meter. This is from X view. And if you look at from Y buckling, it is actually you look from Y axis. So if you look from Y axis, you look at from here. So your eyes is parallel to the Y axis. So your eyes will be parallel to Y axis. You look at here, then you can see the brace and also you can see the column. So from Y axis, you can see the column and also you can see the brace that had been attached at X axis. And you know that for brace it is pin connected. So here you will have a pin fixed connection, and the length is same as the original length is 5 meter. And for buckling shape, from pin go down to fixed, and this is your LE is equal to 0.7 L is equal to 0.7 times 5 LE for pin fix for Y buckling is equal to 3.5 meter. I hope you understand how to analyze a brace column. You need to look from X view for X-axis buckling, and you need to look from Y view for YY buckling. What you see from X view, you just draw, and what you see from Y view, you draw. The difference between X and Y view is the effective length. Here is 3.5, here is 10 meter. This is the difference of the analysis between brace and unbraced column. After you get the effective length, then you calculate for RXX and RYY. Why we need to calculate for RXX and RYY? Because we would like to calculate the slenderness ratio. From slenderness ratio, we know that which axis the column will buckle. So first you calculate RXX. RXX is equal to IXX divided by area square root, and RXX is given in the equation, which is 61.3 times 10 power of negative 6 meter 4 divided by area is given 7.5 times 10 power of negative 3, and you square root is equal to 0.0904 meter. And then for RYY, you take IYY divided by area equal to 0.0556 meter. After that, you calculate for SXX, you LE divided by R XX. LE you take from XX buckling because now it is a X. LE for XX buckling is equal to 10 divided by R, 110.619, and SYY, LE you take from YY axis divided by RYY is equal to 3.5 divided by 0.0556. This one is equal to 62.95. Therefore, as I mentioned previously, the column will buckle at the bigger S value. Based on slenderness ratio value, column will buckle at X axis. Because at X axis, the slenderness ratio, the value is bigger compared to Y axis. And then after that, you can calculate for PCR. PCR for XX buckling and PCR for YY buckling. Why we calculate both, I will explain to you later. Pi square EI XX divided by LE square. You will get and for Y axis you use IYY, this one is equal to after you get the PCR, then we can calculate for allowable load. You know that FOS, factor of safety, is equal to PCR divided by P allowable. We calculate for P allowable at X buckling. Factor of safety is equal to 3. PCR for X is equal to 423 times 0.505 kilonewton divided by P allowable. Therefore, P allowable at X axis is equal to 141.168 kilonewton. And for Y buckling, 3 is equal to 1308.428 divided by P allowable. Therefore, P allowable for Y axis, so X is equal to 436.143 kilonewton. Therefore, the P allowable for this column is equal to 1. So you know that based on S value, the column will buckle at X axis, and also based on P allowable value, then we will choose 141.168 kilonewton. Why we choose the lower value of P allowable? Because the X axis can only sustain 141 kilonewton load. If you choose 436 load, then it will not buckle at Y axis, it will buckle at X axis. So that's why for P allowable, we choose the lowest allowable load, because here the maximum or the allowable load that the X can sustain is only 141. But Y-axis, it can sustain up to 400 kilonewton load. So that's why allowable, we choose this one, 141, and here we will design the column. And it also proves here that from S value, the column will buckle at X-axis. So that's why we choose X-axis, because we know that the highest allowable load that the Y can sustain is more than X. So we choose the critical axis, which is the X-axis. Okay, you need to make a conclusion here. Therefore, which allowable you choose. This is how you analyze a brace column, and the brace here in this example is at the top of the column. Let's take a look at this example. Read the question. Column AB consists of W10 times 39 steel column. Determine the allowable load if the column bracing is at the midpoint, given that E is equal to 200 gigapascal, A is equal to 7,420 millimeter square, factor of safety is equal to 2, Rx and Ry is given. Okay, so same, you need to find the allowable load, which is P allowable. And here it brace in the middle. Stated here, this is in the middle, and usually it is pin connected. And if you look at the diagram, at A is actually pin, and at B also is pin. So here, this is a pin connection. Same as before, first you need to analyze the buckling shape, also the effective length for X buckling and Y buckling. For XX buckling, it is actually you look from X view. Here, this is X, so you look from here. When it is X buckling, then you cannot see the brace. The brace just a point, and this is your pin. This is your pin. So it is actually a pin connection. And the original length is equal to 7.2 meter. Draw your buckling shape. LE is equal to L is equal to 7.2 meter. For YY buckling, which you look from Y view. When you look from Y, you can see the bracing and you can see the column. This is your brace, and it is a pin connection. This is a pin. Up here is a pin. Down here also is a pin. Then you draw the buckling shape, pin to pin and pin to pin. For brace column, the buckling shape is S shape. It will not buckle like this shape because you have a bracing in the middle. Okay, please remember that. From here to here is 3.6 meter. Same goes to down here, 3.6. So LE for pin connection is 1. LE is equal to L. Therefore, LE is equal to 3.6 meter. Same goes at here. LE is equal to L. Therefore, L is equal to 3.6. What if LE here is different from the bottom here? If the value is different, then you choose the bigger value. For example, this is 2 meter, this is 4 meter. Then you take 4 meter for analysis, because you know that the slender column will buckle, means that the long column it will tend to buckle compared to short column. Okay, this is just an example. Since these both are same value, then you just take any value. And after that same, you calculate for SXX and SYY. Because R is given, so you just use the formula LE divided by R. For X value will be RXX, for Y will be RYY. Then you will get XX is equal to 66.667. Slenderness for Y axis will be 71.571. Therefore, it will buckle at Y axis. Okay, and then you calculate for allowable PCR for Y axis, PCR for X axis, and then after that you calculate for P allowable for Y, P allowable for X, and then from here you made a conclusion. And to calculate the P allowable, you use factor of safety formula, PCR divided by P allowable. Factor of safety is given in the question, which is 2. Okay, the last answer you will get is P allowable is equal to 1429.417 kilonewton. This is your P allowable. Please do the calculation and check your answer with this answer. And please try this one. This is an example of the past year exam question in 2017. The figure show, this is the figure. This is a brace column, 8 meter line column, and it is fixed support at the bottom and pin support at top. Fixed support at bottom and pin supported at top. And it is braced at x-axis, which is assumed to be pin connected in the middle of the column. And the geometrical properties such as the area, I-axis and RYY is given. You need to sketch the buckling column, calculate the slenderness ratio, maximum load if factor of safety is equal to 1.5, as well as the ratio of the buckling load and elastic strength. So first you calculate for stress, and then by here you can calculate the ratio. Stress for here is given in the question, and this is the diagram. This is y-axis and here is x-axis, and the column is buckled at x-axis. Okay, please try to do this one, because this is how the question for column will ask in the final exam. If you try this one, then you can learn how to analyze the brace column. We finish all the chapters in mechanics of materials. I hope you understand how to analyze the elements, how to analyze the properties of the material, how to analyze the beam, as well as how to analyze the column. The important here is you know that stress is equal to P over A. So that is the fundamental, the important fundamental all engineer need to know. And you should know how to calculate the support reaction. Support reaction is very important. Okay, you will use the support reactions knowledge until you become an engineer, because if the support reaction is wrong, then everything, all your analysis will be wrong. And then how to draw the shear force diagram and bending moment diagram, that one is very important. And for column, the important thing is for you to know which column or which axis your column will buckle. So make sure you know how to analyze how and how to determine which axis your column will buckle. Okay, I hope that you will get all the fundamental knowledge in this subject so that you can go to a design subject. By that, thank you class.